So in today's video, we're going to take a look at some applied problems involving two triangles in systems. So I spoke a little bit about this in class in terms of systems of equations and how to solve them to try and get you set up for tonight's work. So let's look at example number 1. It says two boats are 75 meters apart. So I'm going to fill that in right away. All right, our two boats here are 75 meters apart. It says the angle of depression from the lighthouse to the further ship is 30 degrees. So that's this angle here because that's my horizontal angle of depression, all right, 30 meters. And to the closer ship is 45. So that's going to be this one. Let's go green. All right. It says, how tall is the lighthouse? So we're looking for the height here of the lighthouse. All right, so that's going to be our H. Now, the first thing we can do is we know that the angle of depression equals the angle of elevation. So if I'm looking here at my 30 degrees, my angle of depression, well, I know that this angle of elevation, because of the sight line and my alternate interior angles, it's going to be 30 degrees. So I'm going to put that in there. And then also I know the other ship, all right, the angle of depression is 45 degrees. So I know this angle of elevation, again, from its sight line, the angle of elevation is going to be 45 degrees. All right, so we have two triangles here that we have to look at. We have the bigger one with 30 degrees. And then we have the smaller one. With 45 degrees. Well, I know the distance between the two ships is 75 meters. And there's really no right triangle connected to that. But I can use that in terms of finding this line, this distance from the lighthouse to the second ship. Well, I know that the distance from the lighthouse to the closest ship has to be x. So the distance from the lighthouse to the furthest ship needs to be x plus 75. Now that should make sense to you. So let's separate these triangles though, because that's a strategy that I told you to use. So that big triangle, I have my height, 30 degrees, and that's going to be x plus 45, x plus 75, sorry. And then the smaller triangle, height's the same for both, that's a shared side. That's going to be 45 degrees. And that's going to be x. All right, now, what I should write down, because I know what I'm going to be using are my trig ratios. So I'm going to write down, TOA. And the two sides that I have are going to be my opposite and my adjacent. So I know I need to use tangent. So I'm going to write down the tangent of 30 degrees equals my opposite, which is h, over my adjacent, which is x plus 75. And then for the green or the smaller triangle, I know that it's going to be the tangent of 45 degrees equals my opposite, which is h, over my adjacent, which is x. Okay, let's finish that up a little bit. So I'm going to draw my line, and I'm going to cross multiply. And when I cross multiply, I'm going to get h equals x times, or x plus, or tangent of 30, sorry, tangent of 30 times x plus 75. And on the other side, once I cross multiply, I'm going to get h equals x times the tangent of 45 degrees. And over here, I forgot my 30. Okay, now, what we should notice, and which is very important, is that I have two equations. And the two equations have two different variables. So I have a system of equations. And this goes back to your algebra and something I discussed, or the concept that I discussed earlier today. So since both of these equations are equal to h, in which I'm trying to find the height of the lighthouse, I can set them equal to each other. So I'm going to have the tangent of 30 degrees times x plus 75 equals x times the tangent of 45 degrees. Now the first thing I'm going to do is I'm going to use my distributive property. So I'm going to distribute the tangent of 30 degrees on this side. When I do that, I get x times the tangent of 30 degrees plus 75 times the tangent of 30. Degrees. And that's going to equal x times the tangent of 45 degrees. Okay, now what I want to do is I want to get my x's. I want to get them on the same side of the equation. So I'm going to move them over. All right, in order to do, and I can do that. And I'm going to do that using subtraction. So I'm going to subtract both sides by x times the tangent of 30 degrees. So I'm going to subtract x times the tangent of 30 degrees. That's going to cancel. And then on this side, I'm going to subtract x times the tangent of 30 degrees. Okay, when I do that, I'm going to get 75 tangent of 30 equals x times the tangent of 45 degrees minus x times the tangent of 30 degrees. Now, something that should jump out at you is that since you have these two, all right, x times the tangent of 45 degrees minus x times the tangent of 30 degrees, you can factor out the x. This goes back all to our algebra skills that you did last year. So I can factor out an x on the right side of the equation. So I have 75 tangent of 30 degrees, that stays the same, equals, well, x that I'm factoring out times the tangent of 45 degrees minus the tangent of 30 degrees. All right, hang in there. We're getting close. Okay, now, again, one of the goals is, and we discussed this today, when I have a system, is to solve for one of the variables. And that's what I've been trying to do. All right, so I need to solve for x, to get x by itself. Well, x now is multiplied times the tangent of 45 degrees minus the tangent of 30 degrees. So I'm going to do the opposite operation to get that x by itself. So I'm going to divide on both sides of the equation the tangent of 45 degrees minus the tangent of 30 degrees. So I'm going to do that. And remember, you have to do that on both sides of the equation. $30. Let's make that clear. All right, that side cancels out, or that's 1. And now I have 75 times the tangent of 30 degrees divided by the tangent of 45 degrees minus the tangent of 30 degrees. That equals x. Okay, now remember, I can take that and substitute it back into one of my equations. I'm going to choose the brown one, the first one. I can choose the green if I want, but the brown one sets up nicely for me. So that brown equation was h equals, and that's my end goal, I want to find h equals x times the tangent of 45 degrees. Okay, well, I know what x is now, so I'm going to sub that in. So now I'm going to have h equals, not x anymore, but 75 times the tangent of 30 degrees divided by the tangent of 45 degrees minus the tangent of 30 degrees. And that's going to be times the tangent of 45 degrees. Okay, now that, be careful, you can plug that in your calculator. Make sure that you're using parentheses, okay, for this side of the equation. And when you do that, you should get that you should get the value h equals 102.45. And if we round, that's going to be the height of the lighthouse is 102. Okay, that's a lot. And I told you today that it was going to be quite a bit. So what I want you to do is I want you to go back, pause the video when you're writing your notes, and go step by step to make sure that you're understanding where we went and our end goals for this problem. All right, now what I also want you to do is write down some key ideas. And I know this video is kind of long, and I apologize for that, but there's quite a bit involved in solving for these systems. So what I want you to do for number 1 is if you can solve it, go ahead and solve it, but at least try to set it up. I really want you to at least try and set it up, and we'll go over that tomorrow. All right, remember, go Cats and go Knights.